the mindset is, okay, this is how we have been doing it over last 40, 50, 70 years. And you are asking us to change.
From EE Tech and All About Circuits, this is Moore's Lobby. I'm your host, Daniel Bogdanoff. Today in the lobby, we're going to dig into the changing world of grid design, how to address the power demands of EVs and modern data centers, and the Energy Trilemma. I'm joined by Dr. Mital Kanabar, Senior Director of Innovation for GE Grid Solutions at GE Vernova. Mital, thanks for being here today. I'm excited for this.
Thank you, Daniel, for having me.
I'm curious, how did you first get into technology and what gets you excited about tech today?
Yeah, so very fast, starting from my, engineering background, I'm from the electrical and computer engineering side. I was even, right from the, the child, I was, playing with the toys, trying to open and break the clock. That's a typical, so we start with. And really from then, getting into the questions, how things works. That's where, your curiosity started with, getting into the engineering side of it, so building something that's meaningful, sort of thing that I was in my high school. Some of the projects I did on just rotating the paper mill and trying to make something that's useful. So that's where I overall started my curiosity towards more electrical. I would say my interest on energy in general. That how you don't see electron, but it drives most of our humanity life. So it was always fascinating in my head that, okay, what's going on in this, metal wire that's keep all this, the machines rotating. That's what you see more of appliances that's functioning. And that's really get me towards the electric side of it. That's really electrifying that you're doing in your, around and keep the life going. And then get that electrical to this more today, the technology pace that's really drive towards more decarbonizations or electrifications, how this can have an impact on human society. If you look at electricity is one of the basic needs as per the United Nations, and look at some of the sustainable development goals that I'm really fascinated with the clean electricity for everyone. And that's a core part of energy security and affordability. That's what we bring. We call it Energy Trilemma. So it's really fascinating how that curiosity has evolved into that. You're contributing towards more larger human society. That needs that very basic needs that we have.
It is such a magical world, and that's what drew me to studying electrical engineering. Also, is you can't see it, but it is kind of an underlying through line of everything we do almost today. Even my mountain bike now has a motor on it. So
yeah,
it's such a useful and powerful tool. But like you said, we need to be able to use it and wield it responsibly. Not to jump too far ahead, and I think where we want to go today, you mentioned the Energy Trilemma. Normally you hear dilemma, but trilemma. So that tells me there's three things going on. Can you kind of outline what is the Energy Trilemma as you see it?
Sure. No, this is a great point. Energy trilemma, as I see it, that you're really trying to balance among the three challenges that are three corners of that, the way it represents a triangle, and one of the aspects is energy security. So how you maintain, especially in this case, electrification. How are you electrifying all of the society, maintaining the reliability and resiliency or availability of those power to where it's needed? The other angle that we have always been, balancing is with affordability. So, you have, security, you have availability of this energy, but is it affordable? Is it accessible to the, human society? The third, angle that we added, which is really put into the trilemma. So you have available, affordable electricity. Can it be sustainable? We are trying to connect more green electrons to the network. So we are not just electrifying the world, but at the same time, responsibility to make it as green as possible through the decarbonization. So I see that that's trying to address all the trilemma the angle of energy security, affordability, and now sustainability.
Wonderful. And I would love to dig into each of those, and we will in a minute. But I was hoping you could first kind of paint the scene for us. What does the future of power consumption look like? We're seeing EVs, we're seeing AI data centers are requiring even more power than, honestly, I thought possible.
Yeah.
What is the landscape of power demand for both the consumer and for enterprises and for countries in the world at large?
Yeah, no, that's a great starting point, Daniel. I think that if you look at it, last electrification system we built over a century, literally. It started, somewhere not too far from here. We have, a legacy of electricity from Thomas Alva Edison, building the generation center at Niagara Falls, and we really, we bring the electricity from there over the century. The challenge today that whatever the infrastructure has been built over the century, we are seeing a 3 times demand increase because of the data centers you mentioned, electrification in general with electric vehicles. So we are really electrifying the transport industry, and some of the process industries, they are also getting transformed to the electrification. So the load growth that what we have seen in my 15 years in this industry is unprecedented with the 3 times load for the infrastructure, which is really I would say several decades old. So at least some of the infrastructure equipment that we see 40, 50, 60 years old. Now you need to use the same infrastructure and adding on top of it, how fast you can go adding infrastructure to make the 3 times increase that what you have been seeing so far in last couple of decades. So it's a really a challenge that my team, and we are in a team Vernova that we are up for, that how do we power our data centers, electric vehicles, the process industry, and as I said, not just electrifying, the same time decarbonizing. So we need to bring the green electrons into or blue electrons, whichever color you call it, onto the grid.
So I assume green electrons are not just like a St. Patrick's Day themed electron. Can you talk me through what is a green or blue electron? Where do they come from? And what does this initiative towards decarbonization look like on a macro scale?
Yeah, no, absolutely. So decarbonizations, we are really, as you generate the energy from, from fossil fuel based, generations, you are really burning, either coal or gas or some kind of, fossil fuel, we call it, right, which generates hydrocarbon in order to, drive your turbine, your machines to generate the energy. Decarbonizations really take the carbon component out of this generation of the electricity. And there are a couple of areas where you can do. You can use renewable resources like wind or solar. So that's called sustainable resources in order to generate. You can use, of course, the storage system in order to maintain the variability of those wind and solar brings. So with the combination of some of the the storage equipment as well as hydro, we seen hydro with the pump storage hydro, you can also generate some of the green electrons. On the other side, we have also been investing into the nuclear energy, so small modular reactor. That's also happening in the same place where I'm located, and we are building one of the world's first small modular reactor that would again generate more green electrons. The other side, if you look at it, hydrogen and some of the other fuel that would also translate. So if I can really generate the hydrogen from the renewables, or whenever the wind is flowing, you convert into the hydrogen, and then that can be transported. So that's another way of hydrogen economy that we call it can bring. And finally, I also want to touch upon that even you might have a gas power, but we are building on a carbon captured technology, so that can even capture the carbon in the part of the process, so you are not really releasing the carbon to the environment. So there are plenty of options that we have in terms of technology portfolio, and that's something exciting as a GE Vernova, that we call it all of the above technologies. So really, whatever I just mentioned, list of those technologies, so that we are our different teams are working at a GE Vernova.
I'm very curious about the small nuclear reactor. I'm a big fan of nuclear power, but it has such a storied and controversial past over the last 50 plus years. Can you tell me a little more about that system and what gets you excited about it?
Sure. Yeah, absolutely. Again, I'm not an expert on the nuclear power. I am on the grid side, but just to give you the perspective that, what we are building, a small modular reactor, SMR, and this technology allows to bring you a small scale modularized approach where you can really put the plants, with, I would say more efficiency, higher speed, as well as you can make it scalable. The modular reactor, that's the technology that's, which is allowing you to generate in a very small scale with, some, flexibility in terms of the fuel. And the idea of here is to, how do you, bring more, we call it dispatchable generation. That means that, you can really have a control over the generations. Now, if you look at wind and solar, you don't have control over when wind will blow or sun will shine, right? If you look at on the fusion side, you have some control over the nuclear fusion, and that's really that, without generating any carbon or burning any fossil fuel, you are really making use of this fusion technology in order to build a small scale controllable green electrons to the grid. So I see, it's very exciting, Daniel, that you can have a renewable, but that's dispatchable. And that's where make this nuclear energy more unique in a nature, that it's more dispatchable, we call it, or more controllable source, but at the same time it's smaller, modular, that you can scale it up faster as well.
Well, and not being subject to the elements is a big one, because I know on the grid side, when the wind blows, that's when you get wind power, and when the sun shines, that's when you get solar. But then you have demand curves. You have the duck curve of consumer demand, kind of looks like an outline of a duck. Can you talk about how maybe EVs, how you see EVs fitting into the overall grid architecture? Is vehicle to grid going to be something you're thinking about, or is it more about supplying and storing power elsewhere and supplying it when it's needed?
Yeah, no, that's a great question. This dark curve, right? It's creating us, a challenge. And just to build on that, very quick, that that dark curve is changing as well. So as we talk electrifications, we have been seeing those, the peak in the grid demand when with the offices starts, or when you move from offices to go back. Some of those peak demands are shifting as well, with newer type of electrified loads that's coming. And you're right, it's always been challenge. I mean, that has been my my team working on how do we maintain the load generation balance. We call it grid reliability, stability, and while maintaining those the stability equations with EV and some of the other data centers, for example, I don't have a control over when you're going to run your AI query on those, and the GPUs will be firing up to will take the loads. So today it has been a real challenge, not just shift in the duck curve, but also the rate of change. The servers and the data center that's running, it can go from 0 to 1 so fast that now you query, and then it's the electronics now, so you can fire the electronics much faster than what we have been doing in the past with the rotating machine starting, which is more gradual. So the shift, it's called a step change in the data center powers and some of the load profiles. How do we manage between those? That's really I would say a core technology, or we call it our GridBeats portfolio. So we are really moving Daniel, from the hardware defined automation solution that every hardware is designed to take a control based on the dark curve, and you're defining how you're going to work, and all this logic or rules was pretty much predefined over centuries, I say. So there are several decades we learned and we hard coded those rules. Now as we see it, this has to be flexible. It cannot be hardware specific or rule based. And we are moving towards our portfolio more software defined automation. So that's what we call it GridBeats. as a software-defined automation solution. And that's very, exciting part of the technology. So now I'm taking the technology, that's what's happening. And technology is giving, data center, being a technology AI, challenging us on the grid. I'm leveraging that technology to be flexible. So it's like trying to, you're using a challenge as an opportunity, and you're also using the same technology trying to build more software-defined automation systems that will allow us to be more flexible. We can manage those kind of, load generation balances. So to your earlier point, let's say, we need more power to certain location of the grid, and the wind doesn't blow or sun doesn't shine. I have to reroute, the electrons from some places where it's available, meaning that, I have to maintain some of those, the level of utilization on the grid. We have automations and control that, the technology that we are building allow us to increase the utilization of those same wires. So we are not going to ask to push that, hey, build more and more, wires, or, the put more cables. We are trying to really, efficiently use more utilization from the same network in order to maintain the grid stability, but at the same time feed those, data centers and some of the critical electric vehicle load step as well. So it's really, I would say, the technology piece that's enabling us to maintain the balance in a real time. And all of this happening every second, or fraction of seconds, so to say.
So how does one build and design a flexible grid? Is it matching up different types of sources so that you can supply power when it's needed? Or what does that look like on a more tactical level?
Yeah, no, that's a great point. At an execution level, I would say that load and generations, data centers connected to the grid through a substations, and generations also connected to substation. There are several, we call it substation, which you have a transformer stepping up, stepping down, as well as some of the control element there. So I would say we have added electron controls over the grid from all the way from generations to the load, and now they are all distributed geographically. So the way flexibility works is through the control. So we need to control those controllable assets that is being deployed across the grid, and leveraging that control element at those substations, which are every node. So you see the grid is more like a network, and network has those nodes where you can take a control actions. And our solutions are deployed at every of those network nodes. And network nodes has a automations which we can take a control action. So if you're passing by, you're curious to see that there are some electric towers, multiple towers ending into some kind of a station where all these wires, cables coming on. It's pretty in a high chance it will be a substation if you're driving by, and at the roadside, and you would see that those substations has equipment which can allow us to take control action. So we really, like my team, we built a brain for those electrons. We sense, same as the human anatomy, that you have all of these nervous systems is actually taking all the measurements, what's happening in your entire network of your system, and that sensing allow us to measure that what's the current state. And these measurements are happening, I would say, a few hundred microseconds. So it's a really fraction of seconds, taking the information in, looking at building that, artificial intelligence, or even a physics-informed intelligence, and taking control actions. As we as a human take control actions with our, controllable, your actuators, your hands, legs, same way that, we have those, controlled mechanisms into the grid. Now, what it allows us in a flexibility term, if I can take the flow, if I can change the control electron, flow control, that would allow me to increase or reduce some of the the loads or the flow of the electrons that is required at a certain level, and I can in real time increase the utilization fraction at some point of the grid nodes while I can reduce it other place. Same way, you have various electric vehicles connected. So if I have a flexibility to control the loads, as I may be able to control the charging at a charging stations, not just individual electric vehicles. That's too small for us. We really like to take a control actions where we are talking about in terms of large electric, where it can be impactful to the grid, like few megawatts to few tens of megawatt of power. And if we can take a control actions by adding that, okay, you charge or discharge at this time, or we use the connected equipment to the grids, to your point, vehicle to the grid, V2G. And that way, instead of really vehicle would be charged when grid don't need power, and we can discharge them in when we really need power into the grid. Same way, I would say, for the data center example, if I may say, behind the meter within the data center, you may build some generations. Let's call it small modular reactor or a gas power with carbon capture, and data centers would be really using those systems with storage, of course. But when data centers don't need the power, they can also be supplied to the grid as well. So we are really building, I would say, bi-directional flow of electrons, so that traditionally the loads have always been consuming. Now they're becoming a prosumers, meaning that you can really leverage the grid power when it's available, and you can feed back power. So that's the level of flexibility with the bi-directional control we are building into the grid.
Yeah, it's such a fascinating concept of the bi-directional power systems, where either a fleet of maybe city buses that are all electric that can store and supply power when it's needed, store it when it's cheap and supply it when it's expensive.
Yes.
There's a lot of opportunity for innovation here. You mentioned some AI ML processing that goes into this. Can you talk about, GridBeats and what specifically is going on there, and what gets you excited and what's getting your customers excited?
Yeah, no, absolutely. Thanks for asking that question. So, a Gridbase is a software-defined automation portfolio, and as I said, we are building more software-defined, meaning that it's flexible. You can change the Gridbase, solutions without changing underlying hardware. So, in the past, if you ask me that, okay, hey, I need, my duck curve is changing. I'm adding more renewables, or you're making some changes. What do I need? What's the scope of change I need to do? So then we have to say, okay, I need to start, and I need to give you all the hardwares and boxes. You have to put more computations, more and more silicon, more and more electronics. In the next generation with Gridbase, we are deploying this in a software, I would say, like hardware agnostic or software defined, meaning that this applications that we are deploying is not dependent on where this deployed. And that way, instead of changing the hardware now to meet the flexibility or the changes happening to the grid, you just need to upgrade the software. It's same like that, you're for any cybersecurity updates, you're not changing your laptop, you're really, that it's upgrading all of those patches, and now you're ready for the new cyber challenges. Same way, we are upgrading our GridBeats solutions in a software-defined way, and then that way allow you to be, meet to the newer challenges and harden you for all of those changes that needs to happen. So that's what we call it, software-defined. And automation, as I mentioned about the flexibility that you need to automate the controls that needs to happen in sub-seconds. Those performance are really coming out of this automation piece. So that's why substation software-defined automation piece, and that's what GridBeats portfolio is about. Now, one of the enabling technology for software-defined automation or GridBeats is artificial intelligence and machine learning, AI ML, and the way it's built through taking building the intelligence from the data driven. So today, in the past, the system has been designed on the physics based. Today, we are trying to learn from that physics-based system or rule-based system. We have a data, we have a physics models, or you can call it digital twin. So we are leveraging all of those, the technology that we have been building over last several decades, and we are, meaningfully using those data sets. such a way that we can build the artificial intelligence models that are, physics informed AI, we call it. And that way it has a physics information in it. It's not just any data model. There are models based on understanding the grid informed, and using those digital twin, we are really training our artificial intelligence model that can further be deployed or working hand in hand with some of this, software-defined automation system that I talked about. Of course, at this stage, we are more deploying it supervisory or monitoring. So still, human is in the loop when it looking into the validations and testing. But of course, in the future, we would be able to see that this systems advanced intelligence, I call it, more than artificial intelligence. This advanced intelligence will really start taking control actions, autonomous grid control actions. So we call it zonal autonomous control as one of the solutions, where we are trying to build more flexibility, but in an autonomous control manner.
Are people building digital, like cities or utilities or large power consumers, are they building digital twins of their own systems, or is this more data you've captured over the last couple decades?
Yeah, no, that's definitely it's one of the challenging area today, and evolving as well. That who owns the data, and certainly the end users, the customers who has deployed these systems owns the data. No questions. Okay, there's a sensitivity around that how this data should be used, as people understand the value of data being used to build a model. The way we are working in terms of digital twin of the models, that first of all, we have a physics model. So we have the grid, how the grid works. We have really put all those equations on the physics level to simulate the grid into our simulations or hardware in the loop, closer to the real world simulation environment. And with having that kind of simulated environment, which is very close and has been validated how close it is to the real system, and has been proven over several decades. So we have a proven simulation environment that we have. Of course, the configurations and parameters that changes based on where you are deploying this simulation environment. So we have been partnering with our through our innovation advisory council with our customers who are actually deploying this kind of systems. Take the configuration parameters, we build this, we run this simulation environment, demonstrate that, that look, data that we are generating, it's called synthetic data. We are really generating out of the, this kind of, simulation environment, but those can be really used. They're close to their systems and can be used into building some of this kind of, AI-based model or software-defined automation systems. Of course, we work with our customers as well when they want to build their own model based on their data, and that's where the power of, we call it grid age. So most of our intelligence that you're seeing it today, it's happening towards more cloud-based. So you need to upload all of your data to some of the public or private cloud. Rather, we are taking an approach towards the edge. So we, as I mentioned about substations, and if you remember those nodes into the grid that I talked about, so the substation nodes, we call it at the edge. So the intelligence is not residing somewhere in a cloud or a central server locations or data centers. The intelligence is at the edge, at those substations. And that's where you deploy the AI model or GridBeats software-defined systems to geographically disperse all those substation nodes. And you are taking it, really, more resilient. It's not dependent on the availability of the cloud or internet. Sometimes in weather conditions, as we know, with the extreme conditions, you may get disconnected. And that's where you really need the hospital to be powered up. So we are trying to build this kind of resiliency through the edge level infrastructure deployment of AI. And that's how we see that, would be more beneficial to the human society as well, that you are making the power available when that's really need for those.
Sounds wonderful. And this, I think, feeds into back to the trifecta we were talking about. Security becomes a very salient topic at this point. Can you talk about what does security look like for utility systems overall? I know I saw a report that said there was a 48% increase in cyber attacks on utilities just in the last 2 years. So what does the role of security look like right now, and what is its role in the trilemma?
Yeah, no, that's a good point. So as we digitize our systems and into the grid, and one of the challenges that allow or like hinder us from going from like accelerations of this energy transition or solving the energy trilemma is that how we can seamlessly make this data or information flow from one place to another, and how fast we can do it, right? So in order to bring this informations at a high speed from end to end, your communication infrastructure needs to be secure. Since the grid is categorized into the critical infrastructure, so there are regulatory requirements in order to maintain the grid reliability, resiliency, security, and for this critical infrastructure, you have to make sure that all the information that's passing through are also going through the secure communication channels. So this is what it creates a challenge. Of course, the way it's deployed in many cases, that but this information's only be transferred meaningfully, meaning that when you need it, wherever you need it. So you're not sending it like an IT system. So that's, we call it OT, operational technology. That you're really making sure that the information says it's not all over the place. So that's the number one. Of course, it has to be built purpose driven information sharing perspective. The other aspect that we call it demilitarized zone. So that's all the informations are at a hierarchical level of structured. So you are confining the informations within the specific DMZ, so that you are not really propagating these informations at every layer or hierarchical layer, meaning that so that you are not bombarding your IT systems. The key element again that's going into the cyber securing this digital grid network is through like some of those putting a DMZs at a substation at the edge level. So if we can secure the edge or at substation nodes, then you are really at all of those endpoints, you are adding one additional layer of security. And solutions that you are building is called like zero trust. Meaning that you are not taking that you are not trusting any particular entity that's communicating or interfacing with. So we have we call it like a certificate authority, and you are adding all of this kind of security without getting into all this technical jargons for cyber tech world. But we are trying to really build more available as well as secure and private network that allows us end-to-end communications, and this is the primary challenge. Then it comes when you have to maintain security, but at the same time those messages has to be communicated on time as well. That we are talking about here like fraction of second in order to communicate from one geographical location where it could be few hundreds of kilometers away, and to maintain that level of availability of those messages on top of this cyber layer is definitely a unique challenge that what our industry is imposing, compared to, of course, there are few other technology out there in the IT world as well that has been tested, but definitely we need more OT cybersecurity that can go into the defense in depth, I would say, into our grid networks.
Yeah, it's a big challenge. I think of the timing being so important, and looking at like the Germany 50 hertz problem where their grid frequency went too low and everything went sideways really fast for them. The timing is so important, but you can't give up security. So it's an interesting dilemma within the trilemma. So we're getting nested dilemmas now. Nested dilemmas.
I like it. Yeah, you're adding the fourth quadrant, so I hope we are not adding more more optimization. But no, that's a great point what you just said, because we have to maintain the reliability, as I mentioned, energy security. So I have to take actions in fraction of second, because as you saw in that case as well, the 50 hertz system, when things goes down, that you have to maintain the frequency of 50 hertz to be able to stabilize your network. You only have a very few seconds that you can turn around and quick those actions, maintain the grid stability, load generation balance, and then bring the frequency back to the 50 hertz where you started. In some part of the world, it could be 60 hertz. The idea is that how would you stabilized on time. At the same time, you're communicating over secure, the channel that you have from one end to another end. And definitely this is the area where I would say more and more skills and development specific to the industry, the requirement. We definitely need more engineers, more people to contribute towards this, the technology development aspects throughout the industry level collaborations. We are working with our customers, our partners, in order to build to solve the energy trilemma, but at the same time maintaining through the communications and cybersecure channels.
What sort of response have you seen from engineers who are actually implementing and deploying these types of systems? Are they hungry for it? Are there barriers to entry? Is there some education required? What's kind of the overall sentiment and adoptability of it?
Sure. And I'll try to answer the engineers to the energy trilemma, solving problems to multiple angles. So number one, our industry, the grid utilities, we are seeing it, unprecedented workforce retirement. So there are several reports out there that the workforce at the overall age is towards the retirement. On other hand, we are seeing the gaps between industry and the academic. So that we need engineers that could come and contribute to solving this energy trilemma problem, but there is a quite a challenge in terms of the skill set that requires to understand electrons, and that has been the I would say less fascinating. So we only have out of 10,000, I would say one of the reports says 1.7 becomes power engineer out of 10,000. So you can see we have a challenge on how we can get access to the power engineers. Now, having the angle on that engineering side, to your question, how utility existing workforce and the engineers that receiving this new tech, right? So this challenge is on I would put it from the angle of course, retiring workforce, the people who are working for several decades, and that's the mindset is, okay, this is how we have been doing it over last 40, 50, 70 years. And you are asking us to change, why I need to be more flexible grid, why dot curve is changing, right? So the education, the learning definitely is required. And then, it's kind of, challenging in terms of change management aspects as well. But how do we bring person's mindset towards more adaptive to the newer environment that we are currently living in, where we need to be more flexible on the grid side as well as from the organization perspective, right? So definitely at the beginning, like the way any human psychology works, push back on any change. That's why I need to change. But when they see the level of changes happening, the level of challenges into the climate actions that's required, and some of the things that are happening on the weather, and once they learn that, okay, I need to change. I need to change my mindset. We need to work together into this to make this planet at a better place. So this is what I have seen over years. Again, it's not one meeting or one time that it's the shift, but it's a gradual change that we have been seeing. I've been experiencing, especially the last 5 years. The engineers were saying, yeah, we don't need it, not in my career, not in my lifetime. They started changing. No, yeah, let's do some pilot, let's test it to see, can this technology, bring those changes or can address the challenges that I'm facing. So huge change that we are seeing. Of course, I'm expecting more change that, in the industry, that, engineers become more and more adaptive to the change and help us in this, transformation of the technology that happening across the grid.
What might a pilot look like? So if someone says, okay, it's time to start seeing what's going to work for me in my scenario, what sort of things might you recommend for someone who's looking to start adopting some of this?
Oh, that's a great point. So look, it's first, it started with the willingness to understand, right, and an openness to explore what are the solutions out there, and also sharing, having a trust, building a trust and relationship that, okay, look, these are the challenges I'm facing. So we really start with the workshop. So it's like, you would have the contact details from Vernova side. I would say reach out to really individuals and arrange a workshop or a short call explaining the challenges that our customer facing. We are engineers always eager to work with our customers and their challenges. We call it, what's the problem worth solving for them. And once we arrange that, a quick workshop that we can lay out, our brainstorming exercise and what are the problem we're solving, our team, builds really a software-defined solution. So meaning that, the GridBeats allows you to be flexible and try. We can help you identify where you should do this kind of pilots. We really want to address the key challenging areas. So in your entire grid network, we don't want to boil the whole ocean. Let's identify a few substation nodes that I talked about. That, okay, these are the nodes where I always start seeing the frequency going down or voltage is not behaving the way we said. There's a data center coming here, or I have a lot of electric infrastructure being deployed going to be here. So you may identify those pain points. And based on those pain points, or you identify jobs to be done, our team of innovations will come up with okay, these are the options or typical solutions you might want to explore. Okay, without getting into commercial discussions, we got very later stage. At the beginning, we really work on the building of solutions, experimenting, testing. And as I said, we have a simulation environment, the real-time digital simulator. So we bring customers parameters, the network configurations into the simulation environment, work with them to demonstrate that this technology for all of these scenarios really work as expected. In some cases, it may not, and then we have to adopt ourselves to build the solutions that would really fit to the pain points. So the way it would really start, Daniel, is the one phone call to the Vernova, our team, and set up for an innovation workshop.
Yeah, I love the idea of finding a pain point, maybe a new, like you said, a new data center going in that's going to already change the paradigm for that system, and finding an interesting way to test new solutions in that environment where it's already going to change and you have to do something anyway.
Yeah,
might as well look at the latest and greatest for sure.
Absolutely.
Okay.
And look, I think that in terms of technology, there are so many technology out there, right? And every technology, you have pros and cons. Like the way you use the AI tools these days, there are so many tools out there, right? And trying to figure out what tools is good for my solutions. And at some point of time, I would say that they would see that, okay, I want to go with this vendor or that vendor solution or that. I would say from innovations and workshop perspective, we can be agnostic to the vendor mindset and really move as a collaborator, as an industry partner, or let's build an ecosystem, I call it, right? And once that ecosystem partnerships that we are exploring, we are really looking into the pain points and what kind of potential option solutions we have. And we typically, as a part of pilot, experiment a couple of solutions. So it doesn't come from a specific vendor and then you're really selecting a vendor or one particular team over the other particular team. I would say really explore as an innovation solutions, experiment with us. We'll give you a couple of options, pros and cons. As a typical engineering project, we do cost benefit analysis, understanding that which technology is right for you, and that's the way you can really make informed decisions going forward.
As we're circling back to the trifecta, affordability is one of the three there. Can you talk about how do you essentially get more for less, right? Like if we want to keep things affordable and we want to make things affordable where they previously were not affordable, we're going to have to bring in more capability, but it can't cost more. Can you talk me through that part of the trilemma?
Yeah, no, that's affordability is really a key challenge. As as you mentioned that we need to do more with the less, and one of the aspects is that now whatever you have, it's old, so you have to do more with the old infrastructure that you have, and still making it cost effective. So this is one of the solution, as I mentioned about what's typical the cost component or affordability component built, right? We call it total cost of ownership. So I divide more into capital expenditures, the capex that you need to address data center. You need more power. I need to add more and more power lines. That's what it means. That's how we have been operating this network. you are adding more loads, or you're coming with a factory there or a data center. That means I need to add more cables so that you can get more electrons to your network. That's the one way of doing it, right? The OPEX costs, operations and maintenance costs. So that means that, okay, I'm operating my network. In order to maintain the operational aspects, I have to add more people and more and more manpower in order to maintain the larger infrastructure now, because you added more and more infrastructure. The way we are trying to help our customer address affordability challenge by optimizing really this O&M cost, which is significant if you look at an overall total cost of ownership equations. By adding, instead of adding those copper wires and the hard infrastructure, we are adding digital infrastructure. So that's what this GridBeats software-defined automations would add. Adding more and more hardware versus adding it as a software component, you can just imagine the level of shift, or in terms of scope reduction, that you need to do. So first step is to really, on affordability, is that to identify the assets. What type of investments that I would need in order to increase the power? Do I really need to add more power lines, or I can digitize and in real time exploit, or I would say, use more power or push more power from the same connections? So that's what we have demonstrated as well, that we can increase 20% utilization of the existing infrastructure with the help of digitalization technology. Other aspects on operations and maintenance costs. If you have to change the hardware, how many people you need for how many days? If you just multiply that, you will get the dollar, numbers for that specific, location. We are trying to reduce, that moving from hardware to the software side. Now you don't need as many people and as many days in order to make a change. So that's where we see the significant, change, Daniel. In some cases, our customer says that, hey, this reduces 50% less, or even, we have seen very aspirant, a very high, numbers in terms of savings with the help of digital infrastructure, or more and more digitalizations or software-defined aspects. So, look, I understand that we need to get more from less. The way I see the technology being an enabler, this is where you can do more with the less. Of course, we are not squeezing out the existing number of the people, or we are not trying to overwork the human factor. We are trying to make their life easier, giving them more technological tools so that they can manage the larger network with the same amount of time that they have. And they have people back home that they want to go back and with the family and then work, really spend time with their family as well. So we're trying to maintain, allowing the technology piece to be more and more accountable for those changes, more adaptive. And that is another way of you can make it this equations balance or trilemma balance on affordability angle as well.
So some smart utilization of the infrastructure that's already there, and then also the ability to reduce operations and maintenance costs through in that same intelligent utilization is a great path to affordability, is what I'm hearing.
Absolutely. And
okay,
as I said, operations reduces your overall affordability improves. That's where you can get more from the every ratepayers money that is paid. So I'm hoping that this will really that we feel that we'll be contributing to the human society by reducing their electricity bill in turn, or making getting more out of every dollar that's spent.
And then the last in our trifecta is sustainability, and we touched on that quite a bit at the beginning. So maybe give me kind of the 30,000-foot, in a nutshell, version of how you view sustainability, and what about that is a dilemma for you and for GE Vernova.
Sure. So for sustainability, of course, GE Vernova, we have a sustainability report. I really encourage it. It's an amazing report. That's where I feel proud working for GE Vernova, which has invested interest in building the electrification systems with decarbonization. So we really electrify and decarbonize the world at a very high level. Sustainability I would say that building more and more decarbonized, electrons or green electrons, as I said, but maintaining the grid reliability, the other two angles, maintaining the energy security and affordability. So we are really building all of the above technology. So we have renewables, wind, solar, hydro, at the same time, small modular reactor. Also I touched upon how carbon capture can allow you to even maintain gas power, suitability for this kind of sustainable solution. So at high level, how do we bring more and more electrified world, which is more on a sustainable resources? We are not going to run out of air or a solar systems or a hydro. Of course, there are challenges, as I mentioned, that we need to maintain the flexibility. But overall, we are seeing that we are building the systems on more and more sustainable sources to generate the green electrons. So that's how I see that all of these three aspects are coming together.
So I now feel like I have a good grasp of the trilemma and see all of these three issues being real concerns, but also it looks like we're on a good path forward to solving some of those. Are each of those addressed by the GridBeats platform, or how would you describe GE Vernova's GridBeats overall?
Sure. No, this is a great question. So yes, we are accelerating energy transition by addressing this energy trilemma problem: energy security, affordability, and sustainability. While addressing or solving this energy trilemma, we are seeing that how do you balance among all of these three? Some of the time, there are each other pulling that. Okay, I will try to be more affordable, then it may not be sustainable. Should it be secure? If it is sustainable, will it maintain the reliability and availability of the network? So definitely, you might have to compromise at some angle. We are enabling through technology. I can balance among all three, meaning you don't have to compromise on energy security while I am giving you the secure, sustainable, or affordable energy. Likewise, other quadrants would remain balanced through the technology element. And that technology, we believe, the Gridbase software-defined automation portfolio allow us to maintain all the three energy trilemma problem and accelerate energy transitions. How? Very simple. You are building it software defined, meaning it is more flexible. You can change those solutions, becoming more adaptive, more intelligent through artificial intelligence and machine learning as a part of those software that you can define into the automation systems. That will allow you to maintain the security, from those wind power with the flexibility that you need, load generation balances, or any control actions for that matter you can take. So I would say at a high level, we bring that level of energy trilemma solutions by maintaining through the flexibility, through the automations, and you can adapt to the change through software-defined aspects of it. So that's where the GridBeats software-defined automation solutions help to solve energy trilemma.
Well, we're right near the top of our time. I'd like to ask a quick question or two at the end. Question for you. If you could wave a magic wand and either change a parameter of physics or create a kind of dream device that would be like the solution to all of GE Vernova's design problems or customers' grid problems, what would you do with that magic wand?
That's a great question. Look, end of the day, I see that we are trying to make this planet better place, and trying to build more and more sustainably. So if I were to use the magic wand, there are certain areas that we would definitely need electricity and energy. You have to maintain the energy security, affordability, and sustainability. I would put my magic wand to address all these three trilemma challenge or anything future that matter evolving for our next generation. How can I bring more and more sustainable planet through the electrifications? The energy need would be there. I cannot eliminate with my magic wand the need for the energy, but how do I bring this green energy towards their network? I would select that I would use my magic wand to bring the grid flexibility network that that you have a power where you need, and maintain the overall energy trilemma or sustainability over this planet. So maybe it's a long answer, but that's really I'm inspired. That's what I'm working towards. It's not a magic. Still, we are trying to solve the energy trilemma through the same eye of electrification and decarbonization.
That is a very noble answer, and I love it. Thank you so much for your time today. This was fascinating. And where should people go if they want to learn more about integrating GE Vernova into their systems?
Oh, that's a great point. Yeah, we of course GE Vernova website. I would say like this. Look for the GE Vernova. Within that, of course, we are part of the electrifications, and even I have we have a blog as well. So Think Grid is one of the the place where you can find non-commercial, just the thought process of the thought leadership in terms of explaining what is the role of grid in overall energy trilemma solutions. So I really encourage you to look for GE Vernova or Think Grid website that you will find all the information that I talked about today.
Wonderful. Well, thank you so much for being here. This was wonderful.
Great. Likewise, I really enjoyed all the conversations and all the questions. Thank you so much, Daniel, for having me.
That was Dr. Mital Kanabar, Senior Director of Innovation for GE Grid Solutions at GE Vernova. If you liked this episode, please share it with a friend who might like it too. That's how this podcast grows. And also, come let us know on the Moore's Lobby and All About Circuits social pages. I'm your host, Daniel Bogdanoff. Thank you for joining me today on Moore's Lobby. I'll see you back here in the next episode. We got a guest from 3M coming up. It'll be a good one.